A single input enters the network. At first, the signal is stable and easy to understand, but at every layer, the signal is multiplied by weights, causing its magnitude to grow larger and larger. Skip connections keep feeding this amplified signal forward again and again. What begins as a small increase soon becomes a chain reaction. The deeper the network goes, the bigger the activation becomes, until the original information is buried beneath exploding magnitude and noise. The network is no longer controlling the signal, it is being overwhelmed by it.
So, welcome everybody. And in the previous section, we just saw that how your magnitude keeps rising after layer by layer multiplication through a neural network. And soon the magnitude becomes so much that the network is not able to understand what was the initial input and how we can process it. It's a great problem in deep neural networks where we have layers and layers of multiplication. So to stop a network from increasing too much and get out of control, we use something called as RMS normalization. It's a normalization technique that divides your value after every skip connection or after layers of multiplication. We divide the value with the RMS value. How we calculate RMS value? So it is a root mean square. We will go into that, but before I want to show you how it basically works. So if we go to a presentation, we can see that after a skip connection and layers of multiplication, your magnitude rises up, it boils up, and it becomes too huge to handle. But when you apply a RMSNorm layer, it handles it. It does not let it grow uncontrollably and keeps it controlled, keeps it normalized. So how do we do it? Let's understand the math behind it. Okay, so let's suppose that we have an initial vector. Let it be x and let it be very simple like 2, 3. The first step, so we are doing root mean square, but we have to read it square mean root. We will start from square, then we will take the mean, and then we take the root, and then divide the whole magnitude with the resulting value. So this is the method of root mean square normalization. First, we are going to take a square root of the vector values. So square of 2, square of 3, and we get 4 and 9. The next step is to take the mean of them. So we just have two values in this vector, so we divide it by 2. So we add 4 and 9 and divide it by 2. We get a value of 6.5. The next is, so square, mean, and now the next step is to take the root. Now we take the root of the mean value and we get 2.55. So guys, this is our root mean square value, and the next step is to normalize all the vector directions with it. So we will divide each direction, like we will divide 2, the x-axis, and the y-axis with 2.55, and we get this new normalized vector. So this is how we control the signal. We normalize it using the RMS value. This does not let the signal go too strong, but it keeps the multiplication in control. And you can apply layers and layers of multiplications through a neural network and through your different skip connections. So now, before the signal was so much exploding, and now we have normalized it. So this is your this is a complete idea of how we do root mean square normalization. Okay, so thanks for watching the whole video. The root mean square normalization is a necessary but and a very small so it's a very small topic, but it's a very necessary topic. I have covered more topics about neural networks and transformers in my whole channel. You can go through the entire playlist of transformers, and the next video will be about multi-headed attention. So thanks for watching this video. I hope you liked it. Please like and subscribe the channel. Thanks for your time, people.